let's take a look at this one. And if you want the full story, feel free to look into the video. But I was talking with a couple of you about problems like these and how at a certain point we're going to arrive at an equation that we already know how to solve from previous modules. And so the trick is, what's new is how to get rid of that square root sign. Right? If we can get rid of that square root sign in this equation, we're going to get an equation that we already know what to do with. And we can kind of go on autopilot. So let's spend the time, invest the time in talking about how does one get rid of a square root?
I'm just guessing here, I forget, but don't you just put the squared on y?
Yes.
Or make it y squared and just take the square root. No.
Right. The Achilles heel of a square root, in other words, that operation which cancels out a square root, is the operation of raising that quantity to the second power. In other words, what we're really trying to do in this equation is we're trying to go from square root of 11y minus 18 to the same expression without the square root on it. We just want to erase that square root. And how we can do that is by applying its inverse operation, which is raising that quantity to the second power. I'm going to add an intermediate step in here just to help explain why it works, but feel free to not always be bound to including this intermediate step in the middle. Because one of the key elements in this module is that we can represent the operation of taking a radical. We can represent any radical using a fractional exponent. So taking a square root is the same as raising that quantity to the power 1 over 2. And viewed in that light, what we're really doing when we're squaring both sides is we're taking a power of a power. And what happens to the exponents when you take a power of a power? We would add them if we were multiplying one quantity by another. But here we're not multiplying, we're taking a power of a power. So that's a higher level operation than multiplying two powers together. This is similar to if I were taking, I don't know, x to the fourth, raising it to the third. John, I think you were telling me a minute ago what we would do in that situation. Multiply the exponents. Right? And so in the example down here at the bottom, I would multiply 1/2 by 2. And what is 1/2 multiplied by 2? It's 1. But what does it mean to raise something to the power 1? Yeah, we don't need to write the power there at all. So that's why squaring both sides works the way that it does. Right? Because a square root really is nothing more than a power, an exponent of 1/2. And when I raise something to the 1/2 power to the second power, that 1/2 and that 2 multiply together to cancel out the exponent and leave us with just the underlying quantity, which we call the radicand. So when I square the right-hand side of this expression, what's left over after that process is just 11y minus 18. As John was saying, though, that also necessitates us squaring the left-hand side. So what used to be y becomes y squared. But that right there is the important new step in this process. To get rid of a radical, if that radical is placed over the entire side of the equation, as it is here, just square both sides. And the radical vanishes. And we're left with an equation that doesn't have any square roots, but it comes at the cost of now having a y squared. But we already know how to solve an equation like this. What does that process look like? What do we need to do to solve the equation y squared equals 11y minus 18? Yeah, let's move all the terms to the left side by adding 18 and by subtracting 11y. And the reason I want to move all those terms from the right side to the left side is why? Yeah, to get the all-important 0. Anytime we have an equation with more than one unlike term involving our variable, getting a 0 on one side unlocks probably the most important skill in the second half of our course. What can we do with the expression on the left-hand side to help solve this equation? We can factor it. This particular example yields really readily to a factoring process. And not to give away too much of the answer, but
2 and 9.
yeah, 2 and 9, both with negative signs, so that when we add them, we get negative 11, okay, and we multiply them, we get positive 18. And because the right-hand side is 0, there's our green light, 0. That lets us do what?
That'd be red light.
Yeah, red light would be stop. Green light is go. It gives us the go-ahead to split the equation into two pieces, each having its own 0, and then solve each of those simpler equations for y. Add 9 to both sides, and add 2 to both sides. And there we go.
Something that you hid by one thing.
That's right. That, as Nico continues to point out, a lot of this new material, that's what it is, right? It's one layer of royal icing on top of a cake that you already know how it tastes. Maybe that's not the best metaphor, but it's...
Sounds good.
Yeah, no, right now I'm kind of hungry, so... yeah, I don't know if I've...
Did you guys have cake today? No.
We did have cake. Now, yeah, we were celebrating a retirement of the previous chair of accounting and finance. So any of you finance majors probably know Professor Stephanie is retiring. So we were having cake today. But yeah, it was something we already knew, something we already have mastered, really, which is a solution of a quadratic equation hidden by one step, the squaring step at the beginning, which gets rid of the radical.